right, guys, we're going to talk about day 3 after we've talked about the investigation about those reflections and stuff. So, what we're going to do is kind of solidify our understanding with that. So, you're going to see me go back to page 10 and look at those graphs and also the table. So, if we take a look, it says after completing the table on page 10, you should now be able to make 4 preliminary inferences as to how to determine based solely on the equation. Okay. If an exponential function will have a graph that represents growth or decay, and then make those inferences in the spaces below. So if we were to go back, there's 2 ways that we could have growth, and we're analyzing the b value. So either b is greater than 1 or in between 0 and 1, and the same holds true for decay, whether it's between 0 and 1 or greater than 1. So let's go back and look at growth where b is greater than 1. So if we were to take a look at our table, you can see here that I have looked and highlighted growth where b is greater than 1. And so notice that on each one of these, there were no reflections. All right. So what I'm going to do is make our connections here that basically says growth when b is greater than 1 and no reflections. All right, so if there are no reflections and the b is greater than 1, then you have growth. Okay, so now let's go back and look where there's growth, but where the b value is between 0 and 1. So let me change my highlighter here. And we're looking for growth where b is in between 0 and 1. So growth, let's take a look at this. Growth. All right. So now let's take a look and look at the number of reflections. There's an x-axis, a y-axis, and another y-axis. So if we look at those inferences, then I can say, okay, well, with there's growth between 0 and 1 where the b value is, and either an x-axis or y-axis reflection. All right, now let's take a look at decay, specifically where b is in between 0 and 1. So let's go back, and we're going to look at decay, where the b value is between 0 and 1. Okay, and now let's take a look at what's happening with each one of those situations. All right, so if the b value is between 0 and 1 and it's decay, that means it's going to be decay as long as there's no reflection. So what we're going to do is come over here and say that the graph is going to be decay if the b value is between 0 and 1 and no reflections. Okay. Now let's go back and look and see what the last case scenario is over here. So let's do, I guess, a green. And so now we've got decay, but we've got where b is greater than 1. And let's take a look at that. So what's happening is when it's decay and the b value is greater than 1, there is at least one reflection. There's a y-axis or an x-axis. So let's make that reference here. Decay when b is greater than 1 and either an x-axis or y-axis reflection. Okay, so now it says, what is the only scenario that's not included in the above inferences? What's the only thing that we didn't kind of talk about? And that would just be a scenario with both the x-axis and y-axis um, reflections. All right. So one of the things that before we go into this table right here, we're going to talk about that scenario right here. But before I do that, I want to well, let's do the first two columns, and then we'll go into the Desmos that I have prepared for you. Let's look at number 1. Is the value of b greater than 1 or in between 0 and 1? So this is the value of b, and so b is between 0 and 1, and there are two reflections. There's a reflection here and a reflection here, so that means that's going to be 2. All right, let's take a look at this guy right here. Remember, b has to be positive, so the b is greater than 1. This is a reflection here and here, so there's two reflections. Again, let me highlight that reflection. Highlight these reflections. Again, there are two reflections. Let's take a look at the b value. B is in between 0 and 1. And now it's asking us to sketch the graph. And so that's where I want you to, I'm going to ask you some questions based on the Desmos graph that I have here. Give me 1 second. All right. Let's take a look at a couple of scenarios. Let's take a look at this normal exponential graph right here. I'm going to add a reflection, and I want you to tell me which axis it reflects across. All right. So I'm adding a negative. Let me get my keyboard up. Right here for the x, and tell me what just happened. Okay. Then I'm going to do the same thing by putting a negative right here for that a value, right? And then what type of reflection just occurred. And then now I want to go back here and let's take a look at if I have this. Well, first let's do this. I have growth. Okay, so my graph is increasing at an increasing rate. Okay, so I have growth at an increasing rate. Now, when I do a negative here, it is reflected over the y, and now it changed it to decay at a decreasing rate. And now let's take a look and see what happens if I add another negative right now. Well, now I am back to increasing, but I'm increasing at a decreasing rate, which means I'm increasing, but the rate of increase is getting smaller and smaller and smaller. So this is what it looks like with no reflections, okay? This is what it looks like with one reflection. That's one reflection, one reflection. Okay, so let's see. With growth, I do one reflection. I have decay. Again, going back to growth, one reflection, I have decay. Now let's take a look at two reflections. I'm back to growth. The only difference is that my rate of the growth is different. So notice that my growth it's still growth, but it's at a decreasing rate compared to growth at an increasing rate. Now let's take a look at this scenario. Let's say that I start off with decay. So here is decay at a decreasing rate. Here's one reflection. Decay changed to growth, going back to decay. Another reflection. The decay changed to growth. Now let's look at two reflections. Now I'm back to decay, but this is a decay at an increasing rate. You can kind of think about our national debt, right? That it just keeps going down and down and down, right, in a negative direction at a very fast pace. Whereas if I have no reflections, it's still decay, but it's at a decreasing rate. All right, so now let's go and take a look at f of x. So notice that we look at this here. We notice we have two reflections, and we would start off with b is between 0 and 1. So with no reflections, that would be decay. With no reflections, that would be decay. But now we've got two reflections. All right, so let's take a look and see what that graph's going to look like here. So this is f of x. So notice that normally we would have, let me go this graph here. We would have a decay, but now what's happening is we have one reflection and then two reflections, and now that's the graph we have. We have decay at an increasing rate, and then all we're doing is moving it to the right 2 spaces and up 3, and we have a little bit of a different base. All right, so we're going to sketch that graph. So just really quickly here, remember though that this 3 is that horizontal asymptote at 3. And then remember, we're going to have decay, but instead of the decay at a decreasing rate, we're going to have a decay at an increasing rate. But it's still decay. And we'll talk about the rates in just a minute. So let's take a look about what we think might happen on number 2. Without any reflections, we would have growth. Now we have two reflections. So I think we're going to be back to growth. The only difference is the rate of the growth. Is it going to be increasing or decreasing at the decreasing rate? So let's take a look over here on Desmos. And let's take a look at G. Okay, so this is my normal one. Okay, the purple is my normal, and the blue is the new one. So the blue, let me check out the blue. First, this purple is a base greater than 1, so it's an growth increasing at an increasing rate. Now let's take a look at G. It's still growth, so two reflections doesn't change the whether it's growth or decay. It just changes the way the graph will look because now it's growth or increasing at a decreasing rate compared to this one, which is purple, which is increasing at an increasing rate. So if we go back here and graph, let me do this here. Let me change the color. So what's happening is we're having growth, but instead of an increasing rate, we have growth at a decreasing rate. And let me be a little bit more specific here because we have our asymptote here. And then remember what we said, if we've got this A value, it's going to be below the asymptote. Okay, so that's another thing to keep in mind. Now let's take a look at number 3. So again, with no reflections, this would be a decay. Okay, so with no reflections, it would be a decay. So with 2, we still end up with decay. The question is, now let's take a look at this. Let's see if we could do this without Desmos. We're going to put this here. Our graph should be below the horizontal asymptote, but normally a decay would be decay at a decreasing rate. But now with 2 reflections, we're going to be a decay at an increasing rate. So that's going to be a decay at an increasing rate. So that's what our graph is going to look like. Let's go ahead and check out Desmos and see if that's what H gives us. There we go. So we have a decay at an increasing rate. All right, so I'm hoping that that was able to, it took a little bit of a more of an explanation, but I'm hoping that that helps you see that. So now what needs to happen is, you know, these 4 inferences that we just made up here, well, we need to fine tune those because it didn't happen, it didn't cover the scenario with both reflections. So now what we need to do is fine tune those so that way we cover both of those scenarios. So let's just take a look. So we're going to have growth. So again, growth can happen when b is greater than 1 and 0 or 2 reflections. Okay. Then the other situation is we can have growth where it has a b value between 0 and 1, but it needs to have only 1 reflection. It doesn't matter which one. It just needs to have 1 reflection only. So now let's take a look at decay. So normal decay is when the b value is between 0 and 1, but you just saw that if you have 0 reflections or 2 reflections, it still remains decay. It still remains decay. The only time decay is going to change is when we have 1 reflection. So B will be greater than 1 and there's 1 reflection. All right. And we'll talk about what properties of exponents make that happen, okay? All right, so here's your chance to try whether or not these are going to be growth or decay. State the reasoning that leads to your conclusions and also state the equation of the horizontal asymptote for each of those functions, okay? All right, so answer those questions and then we will go over that. Okay, so the first thing we want to talk about is looking at the B value. All right, so we need to address um, all of the A and the B and the C values. Okay, so if we were to take a look at this, y equals a b to the power of x, we can say minus h plus k. I think they used C and D. It really doesn't matter, okay, which one it is, so much as you understand what the numbers are and where the locations are. So let's take a look at A. So the A value is negative. So A is less than 0. So the graph of f of x has an x-axis reflection, which means the graph will be below the horizontal asymptote of y equals 3. And again, this value right here is that horizontal asymptote, okay? So now we've addressed the A value and we've addressed this. So now let's talk about the X value, okay? So we've got the X is greater than 0, which means no y-axis reflection. Okay, so what do we have here? We have one reflection. Okay, the B value is greater than 1, which would normally be decay. I'm sorry, which would normally be growth. This means growth, but because there's only one reflection, that means it's going to end up being decay. The B value is greater than 1 with one reflection will indicate decay. Okay. All right. So now let's have you try 2. Let's take a look at the A value. A is greater than 0, right? So the graph of f of x is above the horizontal asymptote of y equals -2. Okay, there's no x-axis reflection. Okay, now the x is less than 0. Okay, so there is a y-axis reflection. Okay, so now we're going to go and talk about the b value. 0 is less than b is less than 1. So remember, normally that would indicate decay. Normally that would indicate decay. But there's one reflection. So that means we're going to end up having growth. Okay, so B is in between 0 and 1 with one reflection. So G of X, that should have been G right here. G of X is, G of X indicates growth. Okay, it's a growth function. All right, now let's take a look at this one. How many reflections do you have? We have 2, which means it's going to end up back where it started with. So let's analyze that real quick. 3 over 2. What's your guess? Is it going to be growth or decay? All right, so let's take a look. We've got A is less than 0. So the graph of h of x is below the horizontal asymptote of y equals 3. Okay. Then we have our x. X is less than 0. So the graph has a y-axis reflection. Okay. B is greater than 1. Okay. B is greater than 1, which normally is growth. Okay. Normally it's growth. There are 2 reflections, so that means it's still growth. Okay. So B is greater than 1 with 2 reflections. So h of x is growth, is a growth function. Okay. All right. So now let's take a look. Hopefully you guys can try and see this using your academic language and notation properly. Let's take a look at this. It says identify each indicated property below. For A, B, and C, write the most specific conclusion that you can make about those values. Okay, so let's take a look. When we read the graph from left to right, our Y values are getting smaller, right? Our Y values are getting more negative, so it's decay. All right, so the justification is it's decreasing. And I am going to say, and this is where I want you to learn how to be specific here, decreasing at an increasing rate. And when I'm talking about at an increasing rate, I'm like, how fast? How fast is it decreasing? How fast is it decreasing? Okay, that's what the question is. All right, how fast is it decreasing? Well, it's going pretty fast. It's going real quick. Left and behavior. So all of these are going to start out the same. As x approaches negative infinity, f of x, and then the right-hand behavior as x approaches positive infinity, f of x approaches. So let's take a look at the left. On the left, we've got the y values approaching 2. And then on the right, the y values are approaching negative infinity. Okay, so the equation of the horizontal asymptote, y equals 2. Now, what can we tell about A, B, and C? And when I say what about A, we're talking about is it positive or negative or what? So let's take a look at the graph. Where is the graph located? It's below the horizontal asymptote, which means A then must be negative. So A is less than 0 because graph is below horizontal asymptote. The B value, okay? Well, we got to think about how many reflections we have, all right? So let's take a look at this. The fact that A is negative, and this is where you have to pay attention. This given form already indicates a y-axis reflection, okay? So remember if it's decay, your B value is in between 0 and 1. The fact that A is also negative shows you that there are 2 reflections. So the B value still is in between 0 and 1. So 0 is less than B is less than 1 because there are 2 reflections and it's decay. Okay? Remember, the equation had the first reflection and then A was the second reflection. Now let's take a look at C. C is going to equal that horizontal asymptote. So C is equal to 2 because y equals 2 is the horizontal asymptote. All right, so let's see what you guys can get on this. Okay, so look at the y values. The y values are getting smaller, so it's decay. All right, but we know that it's decreasing. But how fast? It's decreasing at a decreasing rate. There's only 2 rates, increasing and decreasing. So it's getting smaller at a slower pace. It's not going fast. It's taking a lot longer. So the left in behavior as x goes to negative infinity, g of x, what's happening on the left side, that is going to positive infinity. the right in behavior, what's happening as x goes to infinity, then g of x looks like it is approaching -1. What is the equation of the horizontal asymptote? Y equals -1. The graph is above the horizontal asymptote, which means A is greater than 0 because graph is above horizontal asymptote. Now, there's only one reflection. Okay, so according to this, there's one reflection because A is positive. So when it's one reflection, it's kind of like the opposite of what it normally started out as. So this would indicate that this is decay, right? So normally this would be with no reflections. With no reflections, B would be in between 0 and 1. But you have one reflection. So then that means B is going to be greater than 1. Okay, so B is greater than 1 because G of X is decay with one reflection. Okay, now let's take a look at C. C is equal to -1 because Y equals -1 is the horizontal asymptote. All right, let's take a look at this one. Growth or decay, and then give me that justification. Okay, we can see that it's growth. It is increasing when we read it from left to right. So it's increasing. Is it at a fast rate or a slow rate? We can see that it's increasing rapidly. So it's increasing at an increasing rate. Left end behavior as x approaches negative infinity, h of x approaches, what's happening on the left, it's approaching a -2. As x approaches positive infinity, h of x approaches what's going on to the right. Well, it's approaching positive infinity. Now let's take a look at my horizontal asymptote, y equals -2. Let's take a look at the a value. The a value is above, so a is greater than 0 because the graph is above the horizontal asymptote. So how many reflections do we have? Pay attention to the given function. A is positive. We've already established that. And there's a positive x, which means no reflections. There's no reflections. So that means if this is growth, my B value needs to be greater than 1. Okay. So B is greater than 1 because h of x is growth with no reflections. All right, C value, C is equal to -2 because y equals -2 is the horizontal asymptote. Okay. All right, now let's consider this table. It tells us that it's exponential, and it also indicates that -x, which tells me that it's a y-axis reflection. Okay. You have to always pay attention to that form. So now let's take a look and see what's going on here. See if what you can determine. Is h of x a growth or decay, and give a reason. All right, so when you look at growth or decay, you're going to be reading the graph from left to right. So let's take a look at the y values from left to right, and we notice that they're getting smaller. So that means we have h of x is decay because the y values decrease. So the y values decrease. State the left end behavior. This is the left side. So as x goes to negative infinity, h of x is approaching positive infinity. Okay. Right end behavior. As x approaches positive infinity, h of x is approaching, looks like the number 1. Identify the equation of the horizontal asymptote and give a reason. Well, y is equal to 1 because as your horizontal asymptote is going to be identified as the end behavior. Okay. It could be either left or right, wherever the number is. So as x approaches infinity, h of x approaches 1. All right, is the value of a less than 0 or greater than 0? Okay, let's take a look. If we know that our horizontal asymptote is 1, are these y values higher than 1 or lower than 1? And so a is greater than 0 because all y values are above the horizontal asymptote. Okay, horizontal asymptote is y equals 1, and these are all higher than 1. All right, let's take a look at the b value. Okay, remember, we know that this is decay. How many reflections? Okay, you have to determine how many reflections. Here's one reflection, the y-axis, and this is no other reflection for the a value. So we have a total of 1 reflection. So the only way that B can be decay with 1 reflection is if B is greater than 1. Okay, so let's go ahead and put that in a way. Since h of x is a decay with only a y-axis reflection, then B needs to be greater than 1. What's the value of C? Well, we know that C should be the horizontal asymptote, so C should equal 1 because y equals 1 is the horizontal asymptote. Okay, domain. Well, the domain is going to represent all real numbers, but the range isn't. You have to identify is the graph above or below the horizontal asymptote. So we've already established that the graph is above the horizontal asymptote, so the range is 1 to infinity.